Okay, so today we are going to discuss a system design case, which is like designing a messenger. It's one of the famous question, and it's a little different compared to other systems because it's like a chatting app. Um, um, that it looks very simple, but it has so many complex scenarios, and the workflows are a little longer. Uh, there are many steps of each message, so that's why I think we will learn a lot today. Especially, we'll go in detail, discuss certain workflows, certain scenarios, their failing aspects, and how the overall design will change, and how would we handle all these scenarios. Uh, we can quickly actually go through the initial parts so that we can actually focus more on design and discuss as many scenarios as possible. I think requirements are very simple because everyone has used such systems, and they have an idea how the chat generally works. Um, So over here, we are focusing on Messenger, like the Facebook Messenger, not the WhatsApp design, you can say, because WhatsApp is a little different than Messenger. They only they don't store anything on the server. Uh, it's all the messages and its data is on the client. Uh, they might store it for a little while, but again, it's encrypted, I guess, uh, and they don't store anything on the server side, and the clients are responsible to back up their data and everything. uh, so function requirements aspect is very simple. We are going to focus on two main things. One is one-on-one chat, and the other is group chat. Group chat, you can say more than two people. It's a group chat. Uh, and then the persistent storage of the chat history on the server, uh, meaning all my chats, their messages, their uh, photo, video, anything over there, all is stored on the server too. If I log into a new device, I'll get the history from the server and I'll see it over there. Non-function requirements, of course, reliability. Whatever my messages, my chat, any photo, video should be reliably stored on the server, never lose it, kind of thing. Then highly consistent, uh, which means over here I said like the chat is same on all the devices. You can say you can use phone, tablet, your desktop, and it's the same chat history. It's consistent everywhere. um, uh, Another requirement could be like high availability. The service should be highly available. uh, um, Compared to consistency and availability, of course we want more availability, and consistency over here means what could be consistency. Like one way of consistency is like, okay, all the chat history everywhere is the same. Or you can say that if two people are chatting, the order of the messages is the same everywhere. uh, so, so we really want that consistency. Even if for that, if we have to sacrifice some of availability, we might do it actually. But we want as much available as possible, but consistency is even far more important. It does not it makes no sense if two people are chatting and the order of messages are different for both of them. Okay. That's simple. Like there can be many other things, but we will only focus on just building a chat app, and we'll see even trying to take care of these requirements would require so complex design. um, Practically, it's like it can go crazy. We'll try to limit ourselves and see how things go evolve, and even we can even expand it a little bit. We might go actually try to show notifications, or like the message is seen or read on different party side, how we're changing our design for that, stuff like that. But we'll start with just the one-on-one chat and the group chat and persistent storage on the chat server, on the server side. So let's directly jump on to the metadata database, the actually database, what kind of data we are gonna store on the server. Till now, anyone has any question, comment about the requirement or any confusion here? Otherwise, yeah, looks great. So if you see at a high level, what are the nouns in our system? So one is, of course, the user, the other is the chat, and then a message. You can say these are the three big nouns in our system. So let's have table for all of these. So there's this user table, then there's this chat table, and then you can say a message table, a chat message table. User table is, yeah, go ahead.
Sorry to interrupt. I wasn't sure that what's the best way to ask the question.
Go ahead.
My question is, so the requirements that you have mentioned, are these the requirements given to us, or these are the series of questions that we'll be asking as the interview progress?
Yeah, so that's a good question. They can say design messenger, like even these two words. And then of course you need to clarify what do they really mean by what this is so big, so vague, and you have to ask the questions. But for junior people or even mid-level engineers, they at least put a couple of big requirements to the system. They can say, oh, messenger is so big, but let's focus on one-on-one chat or group chat, or just one-on-one chat. They can limit the system on the requirement as well. But if for like principal level engineers, level 6+, they might even ask you to just design messenger. And at that point, you have to list down requirements, and yeah, this is a big requirement, and I can focus on first 2, 3, and then expand the system from there and see how it goes. This is where your experience comes in, because system design interview actually is there to also evaluate your level of experience, how much you have worked with such systems. I remember in Meta interview training, they actually trained us like asking the same question to a level 4 to 5, 6, 7, and all of them will answer differently because of their background and their experience. And this happens because with experience you really you become expert in making concrete requirements out of vague scenarios given. But for a junior candidate, junior person, it's difficult for them, so they actually give a concrete design requirement to them, right? Did I answer your question, Ali? Yeah. Okay.
I have another question, but I think I'll ask that.
Go ahead. If it's related to requirements or stuff, we can. Yeah.
It's not. I don't know. So what I wanted to know, that is there a general template that should be followed? Should we gradually build the scalability and all the up on the non-functional part, or like how would you recommend to go about this?
Can you repeat again? Your voice cut. Like the non-functional part, where should we handle this?
What I'm saying that is there a template to follow to do the system design interview, like first in the beginning or first iteration focus part that just should be able to, and then iteratively functional requirement and do focus on the non-functional things?
Yeah, even I'll try to answer this question throughout this thing, and this is one of the challenge, but clarify the requirements. That's the first step always. If you read the course Grokking the System Design Interview, that I think in the beginning there's a chapter which gives you a list by list steps. if you they give you a list by list steps that's how you should like start designing your system, which is like a requirement gathering, then give high level design, and then go even detailed design, and finally scale out, find bottlenecks and stuff like that. So there is some guideline, but it could be different for different questions. Like the initial parts where you try to understand the system by figuring out the requirements, or some people can actually say we're going to define APIs over there. That helps you actually understand the system that you're going to build. And some people actually directly jump to the database. They wanted to see the entities they're going to store, because that's how they clarify their system. So again, it's different. You can directly jump to APIs. Like in this case, I mean, I think going for the APIs might not be a big thing, because okay, it's just a message sending, right? You see a message and you're sending it to a chat object, you can say. So maybe it won't define your system more quickly. So it's again battle against time as well. So you need to understand your system quickly so that you can jump onto the serious design parts where you handle other scenarios. But the remaining, the last 3-4 steps where you actually go dig deeper and actually figure out the top 2-3 requirements, and see all the failing scenarios, their scalability scenarios, their non-functional part, let's say in this case highly consistent part is there, what you're going to change. So those are all fixed, you can say. So first 25 minutes you can actually work on with the understanding your system, define the metadata or the APIs or the high level design, and then dig deeper for like maybe 10 minutes, and last 5 minutes or 10 minutes you actually see the complex scenario, scale out or non-functional parts. I think in one of the blog, I have tried to give a breakdown of a system design, how many minutes you can spend. But it could be different for everybody, or the setting of the interview as well. And it's also different for different experience level people. Let's see. I think you'll get a little idea from this question. You can ask this question later in the end too. If you really want more detail, we can discuss it again. So over here, as I said, 3 entities: user, and for user, typical stuff, their name, stuff, email. Chat is an important stuff because chat is an object in our system, and chat means when 2 people or more than 2 people group chat. At that point, we create an object in the database. Chat ID would be the unique, you can say, ID, the identification for the chat object. Title and description could be for chat, and owner is this person that created this chat. And let's say we also put date created of this chat too. Chat user, since a chat can have more than more than one users, so we actually create multiple rows for that. It's one to many. One chat has many users, so for each user we are creating this object, chat ID and user ID, and when they were added to this chat. Yeah, again, it fulfills our basic requirement, and we'll see if we need to expand on this thing or not. Chat message, again, a chat has many messages, again, one to many relationships, so we created a new table, which is it should have a chat ID, like, okay, this is the chat ID of for which this message belongs to, then a message ID, the sender, the person who sent it, the text, which is, you can say, the data. This object ID could be that this message has an object, which could be a photo, a video, which can be stored separately. And over here we have that ID, and from that ID we can actually get that object from storage, file storage, cloud storage. date, time sent, at what time this message was sent. Or you can say like stored on the server. It's one time which is unique, and it also this time can also be used to define the ordering of the messages. Any message which was sent early, it should be shown earlier in the chat message. The chronological ordering is happening because of this. So I think so these 4 tables are sufficient for now for whatever we are discussing, and we'll see if we need to add more fields, more tables, or even altogether have to change the schema. Quickly go through the high level design. Again, it's another try where we try to understand what could be our system will look like. If you see at a very, very simple level, there are 2 people chatting. You can say that we can add more people, and they both can send messages to server. They are the chat servers. You can say they're different servers because these users can connect to different servers. It's a big system, you can assume, and there's so many chat servers, and people randomly connect to random servers, and from there they send a message, and somehow chat servers know each other. And when you send a message, let's say user A sent a message to their server, that server not only store that message, or if that message has a file object, do that storage as well. I mean, run the whole workflow, and also pass that message to the other server, which has the connection to the user B, for which this user is sending a message, and then that server can send a message to user B. That's how you can say that's how the transfer of message will happen. At a very, very simple term, right? So there were like couple of questions that I tried to ask here, like how would what is the best way to find out which server a user is connected to, right? This chat server knows like, okay, this is user A sending a message to this chat object, and that chat object has user B or other users. They need to actually know where is this all those users are connected to such chat server, so they can broadcast that message or send that message to those servers, and then those servers will send the message to the appropriate users. What if the other user is offline? When user A send a message, the other user could be offline. So what will happen in that case? This could be a requirement. We never actually wrote it over here, but you can assume that Messenger allows sending offline messages too. So the many failing scenario, the many unanswered question in this design, but at least again high level, or you understand, okay, there are multiple servers, people are connected to them, sending message to each other, and then there's the storage part where we're permanently storing it. For example, user A, when they come online, they get all the chats they have, chat objects from the server, and then they see the chats, and they can click a chat object, and then another window opens, and we have all the messages of chat, stuff like that. So anyone knows how can we do the step first? What is the best way to find out which server has a user is connected to? I'm trying to send a message to a user, and I'm one of the chat server. How do I know which chat server has that connection to that user, if that user is online, you can say?
Maybe by their IP address.
How would you know the IP address of, like, how would this chat server, let's say 1, know the IP of user B?
There could be multiple ways that can be done.
Yeah.
The easiest could be you can just have the sharding based on a specific geographic or specific user ID. The problem in that case would be that, like, you have to balance those servers users are connected to each shard, right? That you can maintain like Redis cache, having a list of online, and have the registration, or probably like a registry of users connected to a specific server, right? And whenever the message needs to be sent, cache that this is the user I want to reach out, which server it is, and
Yeah. So I think both the approaches you mentioned could work. And let's see one of the approach, that is what I try to propose over here. And we will discuss the other approach too, where you can actually shard or partition your users. Like generally partitioning is referred when you are storing a data, but this was very smartly like said over here that we can actually distribute. It's load balancing of the users. We can actually figure out similar sharding way, partitioning way of the live connected users. Over here I said directory service, which as I said, it can be a cache server, like a Redis kind of thing. It's a key value store, you can say. The key is the user ID, and the value would be the server name or server identification, on which server this user is connected. So now we know, okay, user A, they got a message for user B. They go to the directory service, see where is that user, and then they go to, and they know it's chat server 2. They send that message to chat server 2, and chat server then send the message to user B. So this directory service is a key value store, and it can have all the users and their respective servers. So would this directory, or like for every message, and if a message is sent to many people, it's a group chat, do we have to actually go to the directory servers to get all the active server connections and then pass it over there? Which means for every message we could be hitting this directory service many times. How can we take care of this thing?
We can shard them by user ID. We will have many directory service, but we shard them.
Shard the directory service itself. Okay, multiple partition, and then okay, and yeah, we can
Also,
actually.
We can use Redis PubSub here. Right? They can, because Redis PubSub itself automatically shard. We can shard.
But PubSub, like, what's the idea of using PubSub here?
Because they can, let's say if it's a group chat, they can subscribe with the chat ID or the group ID. When we send the message, they can get automatically from there.
Okay. Yeah. Let's actually jump. Let's discuss it later. This is a very interesting idea. Yeah, go ahead.
Could we have, like, for example, a server that is like for writing the data for the directory service, and then have like another servers for like basically reading the data? So it's kind of like replicating the data in that sense, because it's more like a read heavy than write heavy.
Yeah, it's like, yeah, you can assume it could be read heavy, and you can have multiple copies. You mean replicas, right? And then you can read from any of the replica. Is that you're suggesting?
Mm-hmm. Yeah.
But the original problem is still there. Do we need to, for every message, do we need to check that, this message needs to go to these 50 people? Do we have to like go to the directory service 50 times? Or like even like I'm sending constantly, they're chatting happening between user A and user B. Do I need to constantly go back to you directory service to see, where is user B, where is user B, where is user B? We can definitely like cache. I mean, that's what I'm trying to refer, right? So like, how would cache help, and how much we need to cache, and would cache cause issues? I'm trying to actually just make it interactive. I mean, we can actually discuss, but these are the scenarios we should always think about. So let's make it interactive. I like it. People are proposing different solutions, and we can always think about stuff. So cache can help, definitely help. But what is there? Could there be any issue with the cache?
Could be that the data is old, like after some time.
So what happens, like, old data is fine as far as it's accurate. Like a user is constantly connected to server, a chat server 2, let's say, and I'm fine with it, a directory service. But let's say user B got disconnected, and now they are connected to chat server 3, right? As soon as they are connected, their data is updated in the directory service, but the chat server still cache that, oh, they are on chat server 2. And what will happen in that case?
The message wouldn't go through.
Say it again, Kevin.
The message wouldn't go through, or wouldn't know
Yeah.
where to send it.
Right, yeah. So chat server will they still have cached that, oh, so user B is connected to chat server 2, they send a message over there, and chat server will reply, oh, I don't have that user anymore. So at that point, either they can actually reply, if they know that now where is user B, they can reply with the chat server name, or they can say, oh, I don't know, please find it from the directory service, and they can go to the directory service, right? So overall, I think this overall solved our issue that we'll cache stuff, and sometime the cache will not tell us the correct chat server, but when we go over there, we'll find out, and we'll then at that time we'll consult directory service, or even the chat server amongst themselves, they can help each other. That overall reduce the load on the directory servers, and also we don't have to constantly generate this within the network traffic to the directory service for every message. So that was the crucial part.
I mean,
Yeah,
can we
some-
also, oh, sorry.
Oh, go ahead, Kevin. I'll ask after.
Oh, I was gonna say, couldn't also, once if a user updated their this chat server that they're connected to, couldn't, like, the, I guess, directory or the cache or the directory service, like, subscribe to those changes and then, I mean, update the cache accordingly, or for like their chats, or
we can think about some pub sub kind of way that user B's chat server got updated in the directory service, and then directory service works in some pub sub way, and each server that they're, like, for example, chat server 1 is interested about the location of user B, so directory service can publish those changes. We can actually come up with this thing, but overall we need to see how much benefit we are getting, right? If you assume that reconnection happens it's a less frequent scenario, very infrequent scenario. In that case, okay, why too complex the design over here? Simply, okay, we'll have some time, very rarely, failure scenario where we see, oh, user B has disconnected and connected to a different server. At that point, we'll update, and we will see if we can have actually some pub sub model and what benefit we can get. But I mean, overall, whatever you're proposing, we can still do that.
And what if the user is connected from multiple devices? So the user is active on multiple devices, so it's not one location.
Right. Yeah, sorry, your voice actually cut. I don't know, it's probably issue on my end. Can you repeat the question again?
So what if the user is accessing the chat from multiple devices?
Yeah. So so what's the solution? That's a good question. So tell me the solution.
Do we need to cache the messages itself so that every device can just access the cache of the messages?
So you're saying the text of the message, let's say, it's still with the chat server, because chat server 1, user A sent the message, and it needs to go to, let's say, 5 users, and those 5 users are connected to, like, multiple devices too. At that point, user A still has that message in the cache. They store it, or they still hold the message, and because they need to broadcast that message to all the chat servers which has the connection to these required users. So caching in that, yeah.
I think
Go ahead.
chat server as a ability that when it asks the directory service that so directory service return 1 server or 5 server, because the user can be connected from 5 devices, right? So chat to send all
The voice keeps
responded back.
cutting. We don't understand.
Okay, yeah. So
His
I
voice keep cutting.
yeah, okay. So are you guys seeing the same thing? Okay, maybe Ali's Ali, it was you, right? I mean, maybe your voice was breaking. It's definitely breaking for me, but I think I got the idea. You're saying
I'm gonna I'm saying that responsibility comes on the chat server, that when it pings the directory service to get a user, so directory service can return probably 1 location or 5 locations.
yeah,
Server should not limit that it's going to send to all, because given that WhatsApp is signing in from multiple devices,
yes,
if chat server, right, and if the chat the chat it doesn't allow logging in from multiple devices, then this will be taken care by the directory service, that whenever a user logs into directory service 1, that update scenario should remove the other
right, got it, yeah. So overall, the proposal is directory service can return multiple. So it's not a key value store. The value is a list, you can say, not one server. At that point, we can propagate the message to all the connected devices. And in WhatsApp case, which say you can only connect from one device, the issue is not there. But in Messenger's case, you can send the broadcast message to all the devices. I guess, yeah, that's the overall scenario.
Yeah, Arsen?
Yeah, go ahead, Victor.
So in the case, for example, let's say there something happens to, let's say, a few servers, like they go down, and the user IDs, for example, or the chat IDs, they're basically hashed to like a specific server. Would you have to like update the cache and the directory service, or like how would you go about updating those like on the fly?
Yeah. So that's again a very great scenario. So let me actually ask a question, more concrete question around this. Let's say user A. So let's assume, what's the happy scenario? User A send a message to user B. Okay, so it's a 4 or 5 step process. One is when the user A send the message to chat server 1, chat server replies that, oh, we got your message. Then they store that message to the backend storage. They can send the message to the notify again user A that, oh, your message is stored. Then they send the message to chat server 2, and chat server can send a message to user B. And at that point, we can send the notification back in this whole loop where user A gets notified that the message is passed to user B. And then when user B sees the message, then at that point, we can send a notification again. So 4 or 5 steps. All these notifications can flow to both the users in some way, in some sequence, to really see the happy scenario when a message is completely received and, let's say, seen by all the related or the parties which need to see that message. So a failure can happen on all these steps, So one failure is, let's say, let me ask a concrete question over here. The user sent a message to chat server 1. Chat server actually stored that message to the storage, and then let's say chat server sent the message to chat server 2, which sent the message to user B, but then it crashed, right? So we never know that user B got the message or not, and user B is connected to the server. User B will lose the connection too. What will happen in this scenario, and how would we recover? Are there enough components that can recover from this scenario? So that could be a question, right? Anyone can help answering this question? So chat server 2 sent the message to user B, and then it crashed. It lost all the connections, and it did not come back immediately. Like it will come back maybe, let's say 4 or 5 minutes, 1 minute. But right now, what will happen, and how would we recover the message or something?
The message has already been persisted in the database before we sent to the server, right?
Yeah.
So whenever a node comes online or the user B connects to a different chat server, it should initiate lookup in the data to see if there was a message for that user.
Yeah. So user B has to reconnect, and let's say they got reconnected to chat server 3. At that point, when they connect, they have to query all the chat objects and their latest message. They can always send their state back to the server, or these are the last messages of the chats I have, and the server will go and see, confirm.
No.
Oh, it's underneath it.
You wanna put it on?
Yeah.
So, yeah. So this means nothing went wrong, right? Something went wrong, but the system recovered itself. We don't need to do anything extra here. The user B, upon reconnection, they can either re-receive the message if the message was not completely received, or they have received, so they can send the notification, or we have seen it, or the message is received. And at that point, chat server 2 can actually, or chat server 3 in this case, the new server can send the message to the chat server 1 as well, that, oh, the message is received and seen by user B, which is now connected to chat server 3. I mean, they can actually relay that new information to them too, that previously you send that message to chat server 2 and they crashed, they're no more there. So now I own user B, chat server 3, and I want to tell you that the message is received, and also this is the new I'm the server that has no connection with user B. Right? Any other question around this thing?
I have a question about the message passing between server 1 and server 2.
Right.
Are you seeing this as a synchronous message passing, or is this async? So for example, user B, if it is not on chat server 2 anymore, I think you were saying earlier that, server 2 will respond back with saying user B is not here anymore, so go look it up somewhere else.
Yeah.
But chat server 1 has to know, how does it know? I mean, how's the error message getting conveyed to the chat server 1? Unless it's a synchronous request, it has to wait until some sort of async process is done, and then it has to poll.
Yeah. So, right. So let's say in this case, it looked like a synchronous transfer of the message, right? So chat server 1 send that message to all the chat servers, which have a live connection with the users. And one is like the failing scenario that one of the server died. So we don't care. I mean, because now the user will reconnect to the server. What scenario could be there where chat server 1 has to resend that message to some server because of the failing scenario? What could be that scenario? I'm trying to understand what could be that scenario where I mean, since it's a synchronous message and they have the message, and the chat server 1 is the only responsible body here that wants to send this message. What scenario they have to, in what failing scenario they have to resend the message?
So I think, just to be clear, so I'm thinking the message itself, the text itself is already stored in the database. So the communication between server 1 and server 2, I don't think it should include the message content itself. It should just be that, hey, you received a message from user 1, and then server 2 connects with the data storage to retrieve that message. That's what I'm thinking.
Why you think that we have to, why cannot chat server 1 send that text of the message too, as compared to both first they store and the user B has to read the storage? Why not they can directly send? What issues it can create?
There's a lot of sort of data to pass around, and especially if it is synchronous.
So what I see in this case is that what if the chat server by itself crashes and the message is lost?
Okay.
Right. If it hasn't been persisted in database and the chat server by itself crashes, then the message is lost. Like there's no way to tell that, okay, this was a message that was supposed to be delivered, and before I was able to deliver it, I crashed, right?
Right. Yeah. So let's discuss this scenario first and come back to this scenario again. So let's say user A send a message to chat server 1, and without storing to the storage, the chat server 1 crashes, right? What will happen over here and how would we recover from it? So this is because the most important scenario, you can say, I got the message chat server 1, but before I actually completely store it in the storage, I crash. What should I do? Or even to make it even more complex, I was able to, like, maybe I send the message to the storage and it got stored, but I never got a notification that, oh, it's successfully stored, and I crash. So it could, the complex scenario could be the message is already stored, I did not get the notification. I mean, if you want to retry that message, the message is already there in the storage in that case. So how can we handle that scenario?
So from my second scenario first, where the message was read, but it hasn't been communicated across the servers. In that case, if data is persisted, then it's like a one less thing to worry about, persisted flag or not delivered flag or that. And probably as part of our server design, one of the first thing that we would be doing is when a server boots up, it scans and get of them, right? So if when the server boots up and it checks that, okay, there are undelivered messages, let's take care of them. Our problem is to ping them, okay, there just to take care of them. Could you please do that? The problem, the first scenario where not been persisted, those scenario where we will put us lost your message. Because if the server has not been able to persist it and server has crashed, there's no way to do it, right?
Yeah. So let me answer this thing actually, and then we'll go back to the second scenario. User A send a message to chat server 1, and chat server, before it gets it successfully stored it, they crash. The user A, the client on user A, the client part, the client of Messenger, it will see the disconnection, and they'll see a failure as well. That message is failed to deliver, you can say, or like failed to be saved on the server. At that point, what will happen? The client app will reconnect to another server. Okay, so they'll connect to, let's say, chat server D, chat server 4. And the client app itself, user has already typed the message, they have also already pressed the enter, so they are not retyping the message. The client app will retry sending that message to chat server 4 now. So chat server 4 receive the message, go to the storage, store it, and the happy scenario will work again. Which means, again, nothing will change. The message was lost in the transition, you can say, and the new server now takes the responsibility, and the client app was responsible to, maybe, I don't know, I used to remember, I have not used Messenger for a long time, but I do see sometime, oh, message failed, there's a red sign, and after a few seconds that red sign goes away, that, oh, now the message is stored on the server. So again, I think the happy scenario would be that the message gets stored and we did not lose anything, unless the client goes away, the client reinstall, or because that data is only with the client app, and if the client remain live, they get connected to some server chat server 4, and then this whole scenario starts again, and we are happy with it. I guess any question, comment around this thing? I guess the second scenario is more complex, I think so. Maybe I'll ask them, and you guys might have some answer. Now, chat server 1 actually sent the message to the storage, and storage actually saved that message, but and then you crash, right? Now, client app on user A never got the notification that the message is saved or not. They can still show there's a red sign, and they reconnect to chat server 4. Chat server 4 now takes the message, the client message, and go into the storage and store it in that chat object. Now, how would we know that this message was already saved in the database actually? Because the client app still thinks, because they never got the notification. So they send a message, chat server sees it and goes. How do we handle this scenario actually? Would we have 2 copies of the same message in the storage in the same chat object?
Well, the
Maybe
first,
the message could have a unique ID, something like that.
Right.
That could be used to in the server to identify it's already there.
So now, where do you get this unique ID from, right? Who has that unique ID? And how do the client know this ID? I know, what you're saying, but can you elaborate it a little bit more?
I was thinking that the client will generate but I'm not sure. When the client send the message, it generates the unique ID. So already from the client goes with a unique ID, but
right,
maybe that is not just safe, because given that responsibility to the client may not be good, I guess, as a concept.
Some security aspect. Yeah. Okay. So anyone want to elaborate on this idea or have any other answer to this problem?
Probably a hash can be generated for the given message based on the timestamp and the client ID, like some identification from the message header, right? And that hash can be stored in a way. And the reason I'm saying that we can use some identifiers from the header and everything is because the same text or same thing can be sent again by the user. Sometimes we send same message ... multiple. So we need, if a message was being sent on X time or it was being sent on.
Right. Yeah. Your voice break, but I understand. Yeah. So the security aspect of it, that's what Ali was trying to answer, that we can send a hash instead of the actual ID, and then we can use that hash to see, we will rehash it and we will see that if the message is already stored or not.
so I guess sort of a counter thinking, is that worth it? If we assume that the failure scenarios are pretty rare, are we not okay storing the duplicates? What's the harm in that?
So if we store duplicate, the same message gets stored twice. Do you want to show those 2 same message to both the clients too? And they'll be say, oh, there was a failure, but this message was stored twice and it's part of the chat twice. Is it a good experience, or is it okay?
Again, so this is not the best experience, but I think for the efficiency of the system, if you assume this is rare, once in a while, 0.01% of the millions of users see duplicate messages, they'll see, okay, there's something's off, but maybe it's not a big deal. Of course, we don't want to have every user seeing duplicate messages most of the time, right? So this is again assuming a scenario where this kind of failure is pretty rare.
Yeah.
Can we use the Snowflake to generate the ID? Like each chat server will have own ID, and they will generate the unique ID using Snowflake.
Yeah. Definitely, we can use something externally of any such thing that can give us unique, because all these unique IDs, by the way, in our system, we need a mechanism to, like, some mechanism to generate it. And that is a very good system design question. The URL shortener we never discuss over here in the bootcamp, but it actually is generating unique IDs also everywhere. Unique IDs are everywhere. It's a good system design question. So one thing is sure, that we need a unique ID, and to answer Shahid's comment, that ID needs to generate beforehand, or the client can send a message and then they don't have any connection of that message with whatever stored in the server. It's just a text message, and please store that message and then reply me back with some unique identification of the message that is sent, so that the client can smartly figure out that, oh, some messages are unique or not. I guess how this works is that whenever you initiate a message, it's a two-step process. Like, you go to the server and say, I have a new message, and the server creates an ID and then hash or something, and generate and attach it to the server, to the message. The client knows the hash, and that message gets stored on the server against that hash and ID on the server side. That's how I think it's in the beginning. There's a ID generation part as well, a two-step process, you can say, before that message actually transferred to the server and stored. I think that is the normal scenario. It might not be a failing scenario where you were trying to refer it as 0.1%, which probably is right, but it might not be. In actual implementation, if you go in that detail, you might need the ID or some hash of the message beforehand, before like it gets stored on the server, because once you have the hash, now you have some identification in the whole system, and later you can query about that message hash and stuff or anything. Any comment or thoughts around it? Got it, Shahid?
Yep, I think that works better. Thank you.
Yeah. So if you see, what we are trying to do over here is just the normal transfer of messages, and just storing it. Like, there's this third part, and there's so many failure scenario, and till now, I think these 5-6 blocks that you see in front of you, other than the clients, they are enough. The reconnection and everything, we survive. We still survived introducing, like, a pub sub kind of way or anything. All these systems, all these workflows are still simple enough, and these components can help solve them. They again, like the Shahid's idea, generally these failing scenarios which happen to 0.001% of the people, and then you have to take care of those scenarios, you have to introduce complex components or complex code over here. The normal scenarios are always happy, straightforward and simple. Yeah. So I lost the thought. There was original thought, but anyway, we might come back to that. So
I have a question, if you don't mind asking. I don't know if it's ahead of its time. So how the database read and write would work out? And what I'm asking, that when we are sending from chat server 2, that hey, message needs to be delivered, right? So the chat, and I think we established that we are just gonna send the ID to chat server 2. So the chat server 2, is it gonna read from main database, or is it gonna read from a read replica? How the read replica and write replica, what could be the
yeah. Got it.
The thing that we haven't discussed in the in the functional requirement, that how real time these.
Okay. Yeah. right? We did not discuss it yet. And I think we did not even conclude that do we need to send a message. They need to read it from the storage, or they can actually straight away. I don't know, what would we say? So this is again a good point to discuss. It's that trade-off discussion which makes you shine out, that you can give some idea that, oh, maybe it will create so much traffic, or some scenario, that, or sending the ID to the chat server 2, which then reads it from the storage, and this will make your system more robust or something. But will it really make your system more efficient or something? That is the discussion. And I mean, even that is the question. I'll post it over here too, that should we send the actual message from chat server 1 to chat server 2, or should we just pass the ID and both are responsible from the storage? And you can assume storage will return it from their cache. So it's because it's the latest message, and latest messages are always cached. So they will return it from the cache, but does it really worth it not sending the message but sending the ID?
So the way I'm thinking it, that there is one network call that has to be done from chat server 1 to chat server 2, whether it includes the message ID or actual message. So that network call is there regardless. Yeah. If we persist it in the database, then, or even in the cache, then it means there's one additional network or IO call that will be done, right? Yeah. So I think persisting in database would increase one IO call, right? But if we just send the message within our between servers, then that would be reduced.
Right. So I guess what you're suggesting, we'll have reduced latency if we pass the message directly, as compared to asking the chat server 2 to read it from another network call and from the storage, another server. So is it appropriate to say that we have reduced latency if we pass the message directly?
That's right, because for chat server 2, if I look at the whole cycle, it still needs to do one IO call just to update the message has been delivered successfully. And the DB calls are generally expensive. Yeah. So we are reducing that call. So the message delivery is faster, right? Yeah. That's how I perceive it.
Okay. And what could be the con over here? What is the problem if we send a message to chat server 2? What issues would we face? Or like, yeah, what are the cons here? Is there any like benefit of actually going to storage to read the message?
So there are two. Message never gets delivered, and this issue exists in both cases, right? It's not going to be like any lesser. The second issue that I see, the network bandwidth would be our servers, there will be higher network traffic. Right. And that's one of the reasons where the limit on the messages come into play, that we are limiting our messages to these many characters. Yeah. That's right.
Right. Yeah. So I guess since the message needs to be passed to that server, either from the database or from the chat server 1, the network payload size will need to be transferred anyway. The other aspect is we'll end up reducing some load from chat servers, because now they are not storing the message and they're just passing a small, notification to other servers, and then they are responsible for getting the message. I don't know. I mean, is it some reduced load? But anyway, it looked like we can send that message text over there to chat server directly. But this synchronous passing of the message, can it cause an issue? Any failing scenario over here, which I guess Shahid or somebody was pointing out, that should we actually try going the asynchronous route, or synchronous is very efficient here? I mean, or definitely when we go asynchronous, we introduce some hop, right? That will definitely gonna increase our latency, but we'll get more, easier broadcasting and benefits of asynchronous over there. But but overall, again, in a system design perspective, synchronous versus asynchronous is another very beautiful concept that should always be discussed. And
yeah, but for the asynchronous, you need the knowledge that the client received or not. This way, you will just throw it and you will forget. You don't know if the client received or not.
Like, I mean, since we did not discuss it, I mean, we have to introduce some component or somebody that needs to then propagate that, oh, the message is received or not, you know. I don't know. Let's actually, yeah, let's quickly actually define it. I don't know. Let's do a message queue kind of thing, right? A message queue / Kafka, right? This will have, you know, let's say, it will have queues. And if you remember some message queues, Kafka design, they have topics, right? Topic, let's say topic, and there's a name of it. Let's say it's called chat 1, 2, 3. So what I'm suggesting, let's say this is one of the design at the top of my head, is like every chat has a topic. So that we'll publish all that messages of that chat to that topic, and then there'll be all people, all related people who are interested in that chat. They'll subscribe to it. So whenever a new message is published, they'll get a notification, and then they can send it to the appropriate users. So let's say there are multiple topics here: chat 1, 2, 3, chat 1, 2, 4, let's say, and go on. Like you can have will have you can say same number of topics as we have chats. So now what will happen that chat server 1, when they will receive a message of our chat, let's say they receive a message to for chat 1, 2, 3, they'll publish that message over here. And let's say chat 1, 2, 3 object, there are like 5 people in it, and all those 5 people are, let's say, on chat server 2 and chat server 3. So chat server 3 will actually subscribe to it. Let's say I'm just putting an arrow over here. So it's a pub/sub model. So chat server 1 is publishing in this case, but chat server 2 could be publishing too when user B is sending message. And everybody who have a user connection, and they have some, so every user that is connected to a server, the server knows what chats they are part of, so they subscribe to all those topics, so that they know every time a new message is published to that chat or that topic in this case. In this case, this becomes asynchronous, that now chat server 1 doesn't really need to know in this case that where is user B connected to, and I don't need to pass that message to them too. I just publish it to the Kafka topic, and then from there it will be taken care. Means the chat server 2 will get that message, send it to user B, and then they know the notification, and they have to pass the notification to user A. For that, if you want to send asynchronous the old way, they go to the directory service, find where the user A is connected, and they send the notification over there that the message is transferred to chat server 1. That could be the asynchronous way. This is one of the design, I guess, right now in my mind is, did we actually solve any problem here by going asynchronous or with this Kafka, or what issues we introduced? That is the main question actually. Anyone want to comment on this?
Wouldn't the data recover in case of something crashes?
Say it again, your voice broke.
Sorry. I'm saying, wouldn't the data recovery would be difficult in this setup, like in the queues and Kafka setup?
Data recovery, like what, a message like a data storage server crashed, or like what kind of data recovery?
Like if Kafka servers are crashed, or like we have to recover messages from there, something happens in the, how would that happen?
Yeah, well, that is equivalent to even your storage server crash, right? So Kafka, you can say it's the same way a Kafka server can crash, which, I mean, ideally, like when we would say server means, let's say one of the partition crashed. So they should have their own, recovery mechanisms, replicas or other stuff, or the data is distributed enough. Similarly with the storage, right? Your storage server, which is, let's say, one of your MySQL servers, and say one of the instance crashes, then how would you recover? There must be a copy of it, or a bin log, or any where you can recover this thing. I guess yeah, the discussion is good. Yeah, go ahead.
I was thinking that one problem that it could solve is this message is cannot be lost because it's stored in Kafka. I mean, at least for some time. And so we can, once we get a confirmation from Kafka, we know that was delivered. But one problem that we don't know also is it was delivered to some user, I guess, because if the topic is the chat, well, the chat is one-to-one, basically it's the user. So yeah, we need to get another message from when the user received the message, or not. We want to get that confirmation back.
Yeah, so confirmation, I'm still staying with the older way. We can actually introduce more Kafka topics for users, I guess, to pass that notifications through asynchronous way. But I mean, but before, yeah, go ahead.
And this also, I guess it will reduce, I'm thinking, could reduce the network traffic, because the chats need to communicate with one topic, I guess, and doesn't need to propagate to all the end servers that could be holding the different users, basically, different chat. That could be an improvement, I guess.
Yeah. Yeah. I don't know yet, like what benefit we can get from going asynchronous in this case. Can we say that we don't need to store that message in the data storage, the Kafka storage, because it's a permanent storage as well? You can say it's kind of a database. So each chat is stored in the Kafka topic, and we don't need the storage in the MySQL storage, let's say, and Kafka topic messages in Kafka, one Kafka topic, they're like in the same sequence that we are interested in. And we are always interested in a sequential message way. A chat has multiple messages, but all messages are in this one specific order, and that order is maintained by the Kafka topic, right? Kafka topic. Can we say this? Are we brave enough to not store the message in the storage and just rely on Kafka?
So I'm still not well versed in the Kafka or PubSub like system here, but if we go this way, then float the store, like we can still store the message, but the chat server would not be responsible for that. We can have a separate server, just like our clients, and they can or like they can do the batch update or whatever. And if the requirement is there, persisted.
Yeah. So
I do have one more.
Yeah, go ahead.
I have in this Kafka setup. So in most cases, there's a production and like access be read-only messages. Like read-only access, we can see what messages are being delivered and whatsoever. Like this is one of the things as a product. We're relying on, do we have these kind of access to verify the current state? And I'm talking from an engineer perspective, not a user perspective.
Yeah. So I guess I lost your most crucial point. Can you say it again? Your voice got broken again.
I'm saying that as not a user, as an engineer, if there's a production issue, would we be able to browse Kafka and their current state?
Yeah. Right. You can actually jump onto any message in Kafka, to any index, and you can actually go through all the messages. There's a very interesting discussion once I saw on YouTube. This guy, the designing data intensive guy, is Kafka a data store or not? Is a database? Is Kafka a database or not? And they went with the basic definition. Like, I think overall the conclusion over there was like one critical issue was missing, but overall Kafka can be taken as a storage full-fledged thing. Like a table, you have this topic and everything over there is persistent. You can read message in a sequence, like jumping, or that is, you can still jump, but then like the way a relational database, you can filter and query smartly, or complex queries you can write. That is not possible with Kafka. So that is, you can say, a problem. Like later, if you introduce a search requirement into your chat system, oh, I wanted to just search on a text, that is, I think it's very difficult with Kafka. At that point, it's a clear decision to go with some SQL or MySQL or NoSQL storages. So I guess like if I knew Facebook used to store their data in HBase, which it's kind of, you can say, a columnar store. I don't know what they use now, but the HBase kind of model, which is Google's Bigtable inspired model, or like, yeah, that kind of design where they put messages in a big in a common way that can be accessed in a sequence more easily. That was the idea over there. But over here we were just discussing actually let me actually bring this thing here. Take it step by step.
Awesome.
Yeah, go ahead.
I mean, based on this design, what will be, I mean, your opinion in terms of like best practice? For example, when you have like a chat of, let's say, 3 or 5 people, and one person is removed from the chat, like what kind of, I mean, I'm guessing the directory service and like some of the data will be updated, but like,
yeah,
I mean, what do you think best practice would be in that case?
Yeah. So let's say it's a, let's say, a security issue as well, right? So first of all, you have to go in the chat user table and remove the entry of that user in that way, because now that user is no more part of that chat. So remove it. So in database, it's removed. So you can say the server, the chat server, the person who initiated the removal, which is one of the chat server, they can ask the client to remove the chat from the user which is connected, or I mean, whatever the policy is, if you still want them to see the older message and then no new message. And then you have to propagate the message to directory service as well, you know, that remove this message, remove this I guess, yeah, no, sorry. So now if the user is removed, so now when a new message comes to that chat, it at that point we need to actually invalidate the cache that the chat server is maintaining, which tells the server that what users are part of a chat. So we updated the database, but how do we invalidate the cache? Because every chat server has a cache. They know, oh, this chat has these many users. So if there are 50 users and they are all connected to 50 servers, all those 50 servers have cached this thing that this chat contains these 50 users, so that any one of them when get a message, they send it to everybody. So I guess you have to propagate a message to everybody, invalidate the cache. So that remove this guy from the cache, you can send the message, or you can ask them, please load the users of that chat again from the server, things like that. Did I answer your question?
Yeah, definitely. Thanks.
Yeah. Okay. So the other discussion could be this directory service. It's a it's a single point of failure, very important component, because if it's down, you can assume eventually all chat will start not flowing because now you don't have the map. How do we handle single point of failure in this case? So we said, like, we will cache the entries, and cache, remember, whenever we cache, of course, we are getting something, and now we are faster, we are reducing the load on the servers, but cache has this problem of, at least one big problem of invalidating. Like in this case, when a user is deleted, which is probably a rare scenario, but still that invalidation, removal of the user from the cache happens. So we have to make our system complex. So in this case, directory service, which is, let's assume it's a Redis cache, and we said key and value. Value is a list of devices for that user. How can we get? How can we make it more robust so that the directory service, it's single point of failure? How can we? They're like fixed scenarios you always can use to remove single point of failures, or make them more robust. I guess making copies, making a replica of directory service, would that?
Yeah, I was about probably redundancy, because solve other than making sure caches
We
are.
can use etc or zookeeper.
Yeah, Ali, your voice is always breaking. We're trying to actually understand, but I don't know what happens. Maybe try disconnect and connect again, because it's a little difficult to understand.
You can also try to dial in from the phone. Zoom has a phone option, so you could just call in with the phone number.
Okay, yeah. So that's a good idea too. Thanks, Tariq. Yeah, so I guess directory service, we can make replicas. And
we can follow the master slave, master follower.
Yeah, why would you think
pattern using the etc zookeeper?
Yeah, etc zookeeper, that setting is there. Why do you think a master slave or a primary replica would be more helpful as compared to any other model?
Because if it's one of them crash, other one can continue from the state where the masters live.
Yeah.
So crash will not affect.
Yeah.
You will have the redundancy.
Yeah. So redundancy is there. If we wanted to go with the primary and replica, means all the writes will go to a primary server, which will be replicated to other servers, and anyone can serve read traffic. The data will be, you can say, propagated a little slower. We are going with eventual consistency, but we are fine. If we don't get a user, we can eventually get it, or we can actually try asking the other servers. I don't know, consistency wise, do we get an issue? If I try to connect to a replica and that replica does not really know yet that, or which server the connection is made, the user is connected to, which server the user is connected to, and they assume they are not connected to, so they lose that message. Or they'll assume, oh, this user is not connected. Next time a message comes, they can still go to the directory service. At that point, they might know. I don't know if you have hit that bug in Messenger, where I send this message to a friend and they never get it. And then I press a dot again, or like everybody try to do it and see if they flush the older messages, something. So scenarios like this that we are trying to describe might be the cause of those bugs in your server. I don't know if people can connect to with this thing, or do they understand what problem I'm talking about?
Yeah, I think you're talking about, as there's an iPhone, for example, when the message is not, can't deliver, there's a way to retry. Yeah.
So this directory service is if you understand like how we are load balancing users, that is still missing. We did not draw any those fancy components, API gateway or load balancers, but you can there could be another way. All users connect to like some API gateway, and API gateway then let's do a hash based partitioning or like distribution. So they take the hash of the user and they ask them to connect to any of the server. What I'm trying to, okay, this is user A. What I'm trying to say, let's say this is your API gateway. And the user connects to API gateway. API gateway then forward them to, with some hashing scheme, they can forward them to a chat server, and then this connection, then they have direct connection with one of the chat server, like WebSocket based or something, and they can keep sending messages or notifications to each other. In this way, let's say we are rerouting traffic, distributing traffic, not rerouting, actually routing traffic through API gateway. And we have this hash-based scheme where we just take the hash of the user ID and we know which server should handle it. In this way, when chat server wants to know on which server a particular user would be connected, they can use the same hashing mechanism, right? They have the user ID. Let's say they want to send to the user B. User B's ID is this. Use the same hashing on user B, and then they find out, okay, which chat server they should be connected to, and because this API gateway ensures that algorithm of hashing, you can say, that help us find out which server the user will be connected to. Any thought around this thing, or any idea?
Can you hear me?
Yes.
Okay, sorry about it. Wouldn't in this situation, it will create an imbalance? For example, user of certain user IDs, they will be hashed in a certain way and be connected to one server all the time? Like how the distribution would work out? That's
Yeah. So this distribution is like the normal distribution, you can say. You can use hash-based partitioning in databases as well, right? So since they're using normal distribution, so they assume that your search space is like a bell curve. The hash function ensures that. It's like that mathematics, the complex mathematics of the hash function will ensure that the distribution becomes uniform. Like I'm not an expert around it, but the normal what do they call it? Normal distribution. If you use that, or there's even sophisticated, if you understand your data, the way your data is your IDs in this case, if you understand your IDs search space, so you can actually create a smart, hash function so that the distribution is normal. No other server gets loaded. Yeah, as compared to if you know, we can get rid of this hashing, because this hashing gave us this benefit that the chat server knows the scheme too, and they can then find out which server somebody is connected to. So the directory service goes away, but then this load balancing question that you raised, it comes into action. Let's say an alternate could be a load balancer, where user connects to load balancer. Load balancer knows the load of all the servers, and it simply assign a chat server to this user, and which is random or whatever the load balancing algorithm this load balancer is using. In this way, we are load balancing, keeping the load of the server, and there's no like hard-coded hash function or something. So which means we still need directory service. A load balancer is only helping us distributing the load. No one server become overloaded because the load server is responsible for knowing what are the active load, and based on that they distribute the traffic. I mean, that's what I was trying to say. Go ahead if you have more questions. All right. If you're talking, yeah, we are not hearing you. The other thing we are nearly done, but the other thing we never discussed was the partitioning of the data, right? How can we partition this data? And the challenge again, scalability challenge, and what could be our partitioning key? And again, the motivation behind is what are our usability scenarios? What are our queries? How we are reading the messages, or do we need to write efficiently, or do we need to read efficiently, right? You can say one person is writing, but let's say they're sending a message to 15 people. So it's 15 to 1, all 15 will read that message. So reading is heavy as compared to write in this case. So we need to optimize our read queries too.
What is data storage, like SQL or NoSQL? What would we choose?
Yeah, so this schema that it looked like a relational schema, right? So this is like MySQL, but the actual messages can be, yeah, I mean, you can use a hybrid approach too, right? SQL, MySQL. So you can, as I said, HBase, is HBase considered a NoSQL? I think so. So like they use HBase originally, but you can assume you can use Cassandra to store all your messages. You can jump to any message, or all those things can be done. They're more efficient in storing a sequential data, but they have problems of searching and stuff. So I guess the storage can be done in a SQL server or a NoSQL, but the other, like the chat objects and the user chat objects, they're small, and if there are some complex queries, join queries, you should definitely use a SQL server over here.
What they use in WhatsApp? Do you know? What they use? Because Instagram, for example, they use MySQL.
Yeah.
If you know.
Yeah, like Facebook says they like when this discussion came, like some 10 years ago, SQL versus NoSQL. So they were running one of the biggest fleet of MySQL server. So they say, oh, come to us if you really want to understand how the scaling of SQL storage servers can be done. So I mean, they're proud of it, and they did it. So overall, I think the idea of scalability can be done with SQL servers. It's complex. It has issues. It becomes more complex as your data grows, and if you have made wrong decisions, then it's very difficult for you to you cannot change your schema, right? Over there, and NoSQL, if you have flexibility, then you should definitely go with NoSQL because of the flexibility and easy scalability. But then it has its own limitations, right? The complex joins and all that stuff is very difficult over there. So partitioning, if we just conclude this thing, again, we have 3 nouns: user, chat, and message. When you are partitioning, you can always assume we can partition on any one of these. But what benefit we'll get, again, your query pattern or your storage pattern or your usage pattern should lead you to the appropriate partitioning ID. Let's say if we try to partition user based on user, which means a user and all of their chats, let's say, are stored in one partition, which means every other user can go into different partition. The chat does not have a exact user ID. The chat object has a owner user ID, like who created this thing. So if a person has created many chats, all those chats will be stored in one server, because we said same user, which means owner here. And then so when a chat is stored over there, then the chat messages will be stored over there too. By the way, just a little tangent here, you can actually partition each table separately to make things even more complex. But let's over here, for the simplicity's sake, we will just partition on either, let's say, user ID. So all users data, which means all chats they created and all of their messages will be stored in one partition. This looked like not a good choice, because eventually we only worry about one chat at a time, one chat they matter. Because user, if you see Messenger, there all the chats on the left, and when you click on a chat, you load the right window and you see all the messages. So you work with one chat at a time. So if all the chats are storing in one server, I mean, it's okay, but the scalability can hit a issue over there, right? Because chats can grow as I mean, if you're saying we are storing infinite messages, like your messages are never lost. So it's better to scale on chat as compared to a user. And then also this is tricky, because user who has just created a chat, and based on that, we are storing it over there in one partition. Compared to, let's say, the second strategy could be partition based on chat. So in chat object, okay, user is anywhere, but one chat ID will tell us that where this chat is stored, which means all the chat and all of its messages, which is chat message or even chat users, they are stored in one partition. Now you can say that if this chat grows too big, that eventually in a hypothetical scenario, the whole one storage server contains just one chat, right? Theoretically, it can possible. So we can actually go to that extent, which is the ultimate scalability, you can say. So each chat can scale to infinite, which is the limit of the storage. Or even remember, I think we had a discussion in one of the sessions too, that theoretically, if you overflow even one chat, what can happen? You can take the older messages and move them into the cold storage. I mean, the message is still there, you can search them, but it will be slower. Then we have to introduce the loading mechanism of the cold storage, or like not the actual storage. So this way you can infinitely scale. So the third partitioning was message. Do you really think that if we wanted to partition based on chat messages, that would be like crazy, right? One chat's messages are scattered around different partition, which is not a good idea. So we can ignore it right away. I think so partitioning based on user or partitioning based on chat, they are the most eligible candidates, and look like chat is a clear winner, because that way we can scale, and our query pattern, which is reading the chat messages of a chat, is the most efficient one that fulfills our requirement with this partitioning scheme. Any idea, comment, thought, question?
Just thinking out loud, regarding the partition, I have never seen this, and so just wanted to discuss it out. Regarding partitioning chat messages based on, let's say, time, like month to month, or probably quarterly, right? Because in most cases, as you said, the read query will tell us that what kind of reads are happening, right? So on month to month, let's say a new shard is created and new messages are there. At most, what will happen, there will be a rollover like a couple of days, or probably even it can be spread around quarterly, right?
Right. Yeah. So you're suggesting that based on the timestamp, like let's say all this latest messages are stored in some server, and after let's say a day or two or a quarter or whatever, then we have a new partition. So for every fixed interval, 1 month or say, all the messages are going to that one server. I mean, this is a partitioning scheme, but what are the problems to this one? If you see, all the new messages are going to this one partition. So this one, because everything new is going to store in a few set of servers, and then those are read most frequently as well. So every load, all the load is on those servers, and all the previous servers are just sitting idle. So it's better to not partition this way, because you want to distribute your not only read but write load as well. Did I answer your question?
You did, but I want to take a step back and say I have never seen a sharding happen based on the time of certain events, right? Is this a good approach that can be taught in certain scenarios, or it's generally not preferred?
Oh, partitioning on time, huh? Partitioning on time. Like we have to think about some scenario. Partitioning on time. I don't know what could be the scenario. If we wanted to partition on every second, let's say the second is getting stored somewhere, the second is stored somewhere else. This is like in 1 second, let's say you get like maximum 10,000 messages or something very high frequent, and you're partitioning based on a second or a minute or even an hour. I don't know. It would be like it. I mean, it has to be some system, right? I don't know. On top of my head, what kind of system would get benefit from this thing? Generally, based on like all these systems, generally these systems are not partition based on time because of the reason I gave you. We don't want all the read and write happening to few servers all the time. Ideal is it should distribute. Yeah, I guess if I get some idea, maybe I'll post it in the chat. Maybe it's a good idea to ask it to ChatGPT. They might actually give you a good answer to this thing. I'll try to do the same too. It's a brainstorming session. All right.
Hey,
So,
Arslan, I have a very generic question. So while explaining, you took an example of MQ or Kafka when you drew PubSub.
Yes.
But what would be the similar thing for like chat server or directory service here?
Oh, you can use a message queue like you're saying what is the alternate of a message queue for a chatting?
No, you gave an example of MQ or Kafka for PubSub, but when it comes to chat server or a directory service, what would be those examples?
Oh, like what are those components that are ready-made available?
Right, and that's another question. Like, do I think about them as something commercially available, or are this more, I should think of them as custom in-house kind of a thing?
Yes. So when we say Kafka, you don't have to describe a lot of stuff. So I think it's appropriate to use some technology which is well known, or even not even well known. You can attach it to some concept. For example, when we said directory service, we also actually named another component, which is like Redis, right? So Redis is a key value store, you can say. It's a cache kind of thing, but it actually provides you permanent storage too. So for example, over there, and I think when I said Redis, most of the people, they connected with it very easily. So in a system design, you can actually refer to technologies, and actually it saves a lot of time. It also shows your experience. You're talking about cache, you go with Memcache or like any top of the shelf system.
Okay.
Right? So directory service in this case, like if you want API gateway generic enough, but if you really wanted to specify something, if you know about some technologies, you can actually always talk about like data storage. If you really wanted to, let's say, talk about, for example, there are NoSQL databases and SQL databases, and then there is Postgres, which is a SQL kind of database, and they are giving you a NoSQL kind of features, like, right? So you can actually name the technology over there, because they're saying, oh, they are trying to adopt to the NoSQL word and trying to give that flexibility. If you really you have some experience and your use case demands that too. Even if you go not the top companies, but smaller companies are even they're happy when you name a technology, actually, in my experience. Okay. Because if you understand, smaller companies, they generally try to use any system that is available, whereas all these big companies, the FANGs or all that they're big enough that they generally either if they take some open source system, they either customize it or they have to write it. So all the storage and all the compute, MapReduce kind of systems, everything, they have written their own. Imagine like Facebook Messenger storing their messages to let's say S3, right? That would be a very big budget. So they have to create their own system stuff. So anyway, I think you can put the actual technology name to any component, and it always saves time. Yeah, so it's recommended, actually.
Okay, that helps. But at the same time, can you give me an example for this directory service? Is this something similar to the Active Directory or Okta, or is this something different?
So Active directory service over here is a Redis cache, which is a
Redis cache. Okay, sorry.
Redis,
yeah. Said that. And for chat server, what would that be?
Chat server is, you can say, it's simple. When we call it app server, application server, the actual server where you have written a system which understand your workflow. The sending of message, receiving, notification, all that. That is your core code, you can say. Yeah. So we never discussed this notification queue, but like this will be used for the offline messages. So user A send a message to user B is offline. So this will go into the notification queue, and then we use a notification service which understands the what you call the push notification mechanism. Like in Messenger, if I'm offline or so they send me a push notification and I get the message, and then I can open it too. So that mechanism can be handled over here. Yeah. All right, cool. If anyone has no comment or question, we can finish it here.